So one of the things, as the lead scientist for the Mars exploration program, is wondering whether or not life ever got started on Mars, and whether or not there's the potential that it could even still be there today. So this is the next rover that we're going to send to Mars. It's going to launch, the window opens November 25th, 2011, so not too far away. And this is the most sophisticated spacecraft we ever sent to the surface of a planet. It is a roving analytical laboratory, and it is in fact going to do a fantastic amount of science. It is powered by an RTG, radioisotope thermal generator, so this will last. The warranty is for 1 Mars year, and how much further beyond that it goes, who knows, but we have high expectations. This rover is going to go to a spectacular place, Gale Crater. This particular landing site has in front of it a 5-kilometer stratigraphy that it can explore, and we are fairly confident that it's going to explore ancient Mars up through present Mars, and it go through the transition when Mars changed from being a somewhat neutral and wetter planet to a drier and more acidic planet. One of the ways that this rover will in fact go about exploring is that it has a stereo camera with 12 different filters on it so that it can get rock color, so to speak, but also get a handle on spotting certain mineralogies. Also, a new type of instrument that we're sending to another planet is ChemCam, which is a type of laser-induced breakdown spectrometer. And what this does is it shoots a laser at a rock, and from the plasma generated, it can tell you what the elemental and small constituent makeup of that rock is. It has this arm with the brush to clean off rocks, a hand lens to look at rocks, and also it has the ability to drill and take samples and feed them into the analytical laboratory. And the analytical laboratory is 2 different instruments. One is a XRD, XRF, that means X-ray diffraction, X-ray fluorescence, so it gives you mineralogy. And the other instrument is a gas chromatograph mass spectrometer. So it's able to break down compounds and give you the weight of its constituents, and out of that you can derive what the original makeup of the compounds or minerals that originally fed to it. So in this way, this rover can look around in an area, analyze a few rocks for their elemental composition, and then decide which ones they will go up to and go into more in-depth contact measurements, and also maybe even take samples. So this is extremely powerful, and will be able to tell us what the rocks are made out of, what minerals they are, and also whether or not there are any organics, which is one of the keys to understanding what could have happened on Mars in its past and what may be happening there today. At the same time that life got started on Earth, Mars was a warmer and wetter planet and has the potential, we think, to have had life start there. The big advantage that Mars has is that because it doesn't have plate tectonics, at least anymore, is that you go to the surface, and half the surface on Mars is ancient. So you can go and pick up a rock that's 4.5 billion years old. On Earth, older than 2 billion years ago, the number of places where you can even find a rock that's that old is few and far between. From working in extreme environments, understanding the limits to life here on Earth is that if we find a place where there is liquid water with a water activity above 0.6, then there's a really good chance that life could live on Mars. Now, having, let's say, the conditions such that life could live there doesn't mean that there is life there. And so if let's say you have enough water and we still don't see any evidence of life on Mars, then you'd have to ask the question of, if not, why not? And so that leads to a whole area of research itself in terms of another limit to life that we may not have recognized.